Second derivative affects the concavity of a graph. Here are examples of what concavity is. This would be considered concave up. Notice how it is curved upwards. And this would be an example of concave down, where this is curved downwards. It just depends on what your perspective is. If the x is the perspective from which I'm observing this, then this would be concave down and this would be concave up. So what's happening with concavity? Well, the second derivative is causing this because if I look at these tangent lines, they begin to increase, which means that the slope, or the velocity, is continually increasing. So the rate of change of the rate of change is increasing. Here, the velocity, or the rate of change, is decreasing. So the rate of change of the rate of change is decreasing. So that's what the second derivative is. The second derivative is acceleration. So it's controlling at what the change in velocity is. That is what acceleration is. So it's a fairly simple test and idea. So here is just a graph, and I just want to have a look at it and then identify the different concave up and concave down parts. So from here to about here, not that badly drawn. Say that this interval is concave up, this would be concave down up to right about here. And then this would be concave up till right about here, and then it becomes concave down again. At these points where the concavity changes are called inflection points. And to use this second derivative test, it's very similar to the first derivative test. I solve for the second derivative of a function, and then I make the chart like I did the first derivative. So I find where it's equal to 0, and then I find those points, and then I make a chart like I did last time, and then I look on the different intervals, and if the second derivative is positive, then it's concave up. If it's negative, then it's concave down. Well, so let me look. A, B, C, something like this. So A, B, and C. So if to the left of A, the second derivative would be positive. To the right of it, it would be negative. Left of B is negative. Right of B is positive. Left of C is positive. Right of C is negative. So this is how a test like this would work. It's very simple. It's essentially a repeat of the first derivative test. It just tells us something different.